China literally just put a chip inside a man's brain. No wires, no external hardware, nothing visible at all. Just a coin-sized device sitting silently inside the skull of a man named Mr. Zhang, who had not moved his body below the neck since 2022. Doctors tried everything. Over a year of rehabilitation changed nothing. His world had shrunk to the size of the room he could see but could not move through. Then the chip went in, and everything changed. Within weeks of that surgery, robotic dogs were walking to Mr. Zhang's front door, collecting his food deliveries and carrying them back to him, commanded entirely by his thoughts. He was navigating a smart wheelchair through outdoor terrain and down staircase using nothing but his mind. He was controlling a computer cursor with brain signals alone, and then came the detail that stopped scientists cold. Mr. Zhang has a job, a real paying job. He sorts products remotely every day by controlling a cursor with his thoughts. He receives a paycheck. He is the first brain-computer interface trial participant in human history to perform paid employment using a brain implant. 3 years after his injury ended his working life, his brain is doing his body's work for him. And here's what you need to understand right away. This is not a Neuralink story. This did not happen in a Silicon Valley lab or a California hospital. This was built by the Chinese Academy of Sciences, implanted at a Chinese hospital, and announced to the world in December 2025. While most people were still trying to understand what a brain implant even was, China had already put one in a man's head and sent him back to work. But Mr. Zhang is not the only one, because in the same calendar year, 4 separate Chinese institutions produced 4 separate breakthroughs in 4 different patients. A 34-year-old man paralyzed for 2 years walked again within 24 hours of surgery. A 67-year-old woman with ALS, unable to speak for months, thought the words "I want to eat" and watched them appear on a screen. A 21-year-old epilepsy patient was controlling robotic hands with her brain signals within 5 days of implantation. 4 patients, 4 institutions, 4 breakthroughs, 1 year, and China registered 31 brain-computer interface clinical trials in 2024 alone, triple its own number from the year before. The gap between China and the United States in this technology was once estimated at 8 years. It is now under 3, and it is closing faster than anyone predicted. So what exactly is the device at the center of this? Because the engineering behind it is as remarkable as the results it is producing. The implant is called the WRS-01, developed by CEBSIT, the Center for Excellence in Brain Science and Intelligence Technology at the Chinese Academy of Sciences. It is 26 millimeters in diameter and less than 6 millimeters thick, the size of a coin, half the size of Neuralink's implant. Tiny flexible electrodes sit inside the brain, reading neural signals. A processor chip embedded in the groove in the skull decodes those signals and issues control commands. Fully wireless, fully implanted, nothing sticking out of the patient's head at any point. Now here is the technical detail that separates this from everything that came before it. The electrodes inside the WRS-01 have a cross-sectional area 1/5 to 1/7 the size of Neuralink's electrodes, and they are 100 times more flexible. That combination matters enormously. A thicker, stiffer electrode creates micromotion damage inside brain tissue over time. The brain shifts slightly with every heartbeat, every movement, and a rigid electrode scrapes against surrounding cells with every single one of those movements. China's electrodes are so thin and so flexible that brain cells barely register them as foreign objects. The brain does not fight them, they settle into neural tissue, like they were designed to be there. Stable operation confirmed. No infection, no electrode failure since implantation, and the system decodes neural signals and generates control commands within tens of milliseconds, faster than a human eye can blink. But the WRS-01 story, as remarkable as it is only one of the 4 breakthroughs that happened in China in 2025. Because what Fudan University's team did with their brain-spine interface is something that operates on a completely different scientific principle, and produced a result that made researchers around the world stop and read the data twice. Every brain-computer interface system currently operating in the world, including Neuralink, works by reading brain signals and routing them to an external device. The brain thinks, the signal is decoded, the machine moves. It is powerful technology, but the brain and the body remain disconnected. Broken pathway stays broken. The machine is a workaround, not a repair. What Fudan's brain-spine interface does is fundamentally different. It does not bypass the broken neural pathway, it rebuilds it. Two electrode chips, each just 1 millimeter, are implanted in the brain's motor cortex. A stimulator chip sits in the spine. The brain's movement intentions travel from the cortex chips through the system to the spinal chip, which converts them into electrical stimulation of the paralyzed limbs. And over time, this is the part that genuinely shocked the scientific community. The nervous system begins to rewire itself around that new pathway. The brain is not just controlling a machine, it is learning to reconnect to the body it lost. Researchers call this neural remodeling, and it works. The patient was Lin, 34 years old, paralyzed for 2 years after a fall at work. Told by every doctor he saw that he would never walk again. On January 8, 2025, a surgical team at Fudan University spent 4 hours placing those chips in his brain and spine. The lead researcher said he did not sleep the night before. When Lin woke up 24 hours after the surgery, both of his legs moved. Day 3, he extended and lifted both legs while seated. Day 14, he was stepping over moving obstacles. Day 15, he walked 5 meters with a standing frame. He said, "I used to cry every day. Now I can walk again." Now here's the comparison that puts that result in full context. Switzerland had achieved similar walking restoration results using comparable brain-spine interface technology, and it was considered one of the most celebrated medical breakthroughs of recent years. The Swiss results came after 6 months of intensive post-surgical rehabilitation. China's Fudan team achieved the same outcome in 24 hours. Not 6 months, not 6 weeks, not 6 days. 24 hours after the surgeon closed the incision, the patient's legs moved. That is not an incremental improvement on the Swiss result. That is a different category of outcome entirely, and America's own FDA recognized it, granting Fudan's brain-spine interface its breakthrough therapy designation before China's own regulators had finished their review. The United States regulator looked at Lin walking in 24 hours and gave it the highest fast-track status available. America's FDA called China's brain implant a breakthrough. That does not happen by accident. There are currently 20 million paralyzed people in the world, and there is not a single approved product anywhere on Earth, not in America, not in Europe, not in Japan, nowhere, that restores walking in paralyzed patients. Not one. China is building the first. The target for WRS-01 market entry is 2028. Professor Jia Fumin, the researcher who led the Fudan trials, has stated publicly that by 2030, paralyzed patients will be able to run on their own legs, not walk with assistance, run independently. And in Shanghai right now, Mr. Zhang is sitting in his wheelchair, thinking about where he wants to go, and the chair's already moving. Behind every one of those breakthroughs is a system, not a genius in a garage, not a billionaire with a vision, a coordinated, government-engineered, institutionally backed industrial machine that was built specifically to make this happen, and built faster than any comparable medical technology ecosystem in history. To understand how China produced 4 separate brain implant breakthroughs in a single year, you have to walk into one building in Shanghai's Minhang district. The building is called Brain Smart World, and what happens inside it is unlike anything that exists in American medical technology development. More than 16 brain-computer interface companies operate under one roof. Huashan Hospital, one of China's premier neurosurgical centers, the same hospital that implanted Mr. Zhang's WRS-01 chip, has a dedicated on-site clinic inside the complex. A BCI company developing a device and the neurosurgeon who can implant it into a human patient are separated by an elevator ride. Regulatory expertise is available in the building. Ethics approvals, clinical trial design support, manufacturing consultation, all of it accessible without leaving the complex. Every single friction point that slows the journey from laboratory discovery to patient outcome has been deliberately identified and removed. This is not an accident of geography. This is an engineered environment designed to collapse the distance between invention and deployment. Then in July 2025, 7 Chinese government ministries issued a joint directive on brain-computer interface development. Not one ministry with a budget allocation. Not a single department with a 5-year suggestion. 7 ministries simultaneously. When 7 ministries act together in China, it triggers a cascade. Funding flows from every direction at once. Regulatory priority shifts. Infrastructure gets allocated. Talent pipelines get redirected, and export strategy gets mapped. All pointed at the same target. All moving at the same time. No coordination meetings required, no competing departmental agendas to navigate, just 7 arms of the state pulling in one direction simultaneously. In November 2025, BCI was written into China's 5-year plan, locking in sustained government funding straight through to 2030. This matters in a way that has no American equivalent. A 5-year plan allocation in China does not depend on the next election. It does not get cut when a new administration arrives with different priorities. It does not disappear when the stock market has a bad quarter. The money is committed, it flows. And in December 2025, a dedicated brain science fund of 11.6 billion yuan, $1.65 billion, was announced on top of that. Not raised from investors, not contingent on Series A milestones. Allocated, done. The researchers building China's next brain implant do not need to spend 6 months on a fundraising roadshow before they can hire their next engineer, and then China did something that no other country has done. Before a single brain implant product had received commercial approval, before any device was certified, before any hospital had a product to offer patients, China's national health insurance system pre-approved reimbursement codes for BCI procedures. The government built the payment infrastructure before the product existed. That means the moment any Chinese BCI device receives regulatory approval, hospitals can immediately bill for it, patients can immediately access coverage, and companies can immediately generate revenue. The commercial risk that kills medical technology startups everywhere else in the world, the gap between regulatory approval and insurance reimbursement that can take years to close, was eliminated in advance. Shanghai's Minhang district went further still, offering individual BCI companies subsidies of up to 20 million yuan just to establish operations in the district. The system is not waiting for the technology to mature. It is building the commercial structure first and letting the technology fill it. Chinese BCI companies raised over 5 billion yuan, more than $700 million, across 28 separate funding rounds in 2025 alone. China's BCI market currently stands at $530 million. The projection for 2040 is $16.7 billion, growing at 13.4% annually, the fastest rate of any BCI market in the world. Faster than the United States, faster than Europe, faster than anywhere, and the gap that experts once confidently measured at 8 years is now under 3. That collapse in the estimated lead did not happen because America slowed down. It happened because China accelerated at a rate nobody in the field had modeled as possible. Now look at America. Because this needs to be said clearly and accurately, the United States is not losing this race. Not yet. America built this field. It funded the foundational research. It trained the researchers. The lead scientist at China's own Beijing Institute for Brain Research acknowledged directly that the United States remains the global leader in brain-computer interface technology, and the evidence supports that assessment. Neuralink has implanted 12 patients as of September 2025. In June 2025, it received full FDA commercial approval, a genuinely historic milestone that no BCI company had ever achieved before in history. Patients are browsing the internet, editing YouTube videos, playing chess, and controlling computers entirely with their thoughts. Neuralink is now expanding internationally to Canada, the UK, Germany, and the UAE. This is real, landmark progress. Synchron has 10 patients implanted across the US and Australia, is backed by Jeff Bezos and Bill Gates, and is actively building partnerships with Apple and Nvidia to embed brain signals directly into consumer technology ecosystems. Precision Neuroscience just closed a $102 million Series C funding round. UC Davis researchers achieved 97% accuracy converting ALS patient brain signals to speech, the highest accuracy ever recorded for a brain-to-speech system. The US Brain Initiative has invested $6 billion since 2013. Neuralink alone has raised over $1.6 billion. The depth of American investment and research history in this field has no equal anywhere in the world. But here is the number that reframes everything. The gap between Neuralink's first human trial and China's first human trial, a gap that the field's leading experts had estimated at 8 years, turned out to be 15 months. 15, not 8 years, not 5 years, 15 months. China went from 0 human BC1 trials to matching Neuralink's total patient count in a single calendar year. The gap itself is not the story. The velocity at which it is closing is the story. And that velocity has no precedent in the history of advanced medical technology development. The hardware comparison makes the technical picture even more complicated for America's lead. Neuralink's electrodes are 5 to 7 times thicker in cross-sectional area than China's WRS-01 electrodes. They are 100 times less flexible. These are not minor engineering differences on the margins of performance. A thicker, less flexible electrode causes cumulative micromotion damage inside brain tissue over months and years of operation. The brain shifts slightly with every heartbeat, and a rigid electrode scrapes against surrounding neurons with every single one of those movements. Long-term stability, long-term safety, and long-term biocompatibility all favor the thinner, more flexible design. On the core engineering metric that determines whether a brain implant remains safe and effective 5 years after implantation, China's current system has a structural advantage over America's most advanced device. The FDA gave China's Food and Brain-Spine Interface its Breakthrough Therapy designation before China's own regulators had finished reviewing it. America's regulator is effectively endorsing the competition's work. The most important comparison is not technical though, it is human. Neuralink's trials are demonstrating foundational capability, cursor control, game interaction, internet browsing. These are genuinely remarkable achievements and genuinely historic milestones. But China's trials have produced a paralyzed man with a paying job, a patient walking in 24 hours, a woman whose first thought generated words in months were "I want to eat." The American program is proving that the technology works. The Chinese program is already demonstrating what a different life looks like for people who had been told their life could not be different. Both of those things matter, but they are not the same story, and the story that is coming next is larger than both of them combined. There are 20 million paralyzed people in the world today. There are 450,000 people globally living with ALS at any given moment, fully conscious, fully present, locked inside a body that is progressively shutting down. There is not one approved product anywhere on Earth that gives those people back meaningful movement. Not one. The technology that China demonstrated in January 2025, walking in 24 hours, is the first credible, clinically validated, FDA-designated path toward changing that reality. The WRS-01 is targeting market entry by 2028. The 5-year plan funding runs to 2030. The national health insurance codes are already written. The 16 companies in the Minhang building are already built. And this is only 2025. Subscribe because what happens by 2030 is going to make everything you just watched look like the beginning.